Okay, so we're going to be looking at some good worked examples that will help us apply this central limit theorem to the normal distribution. So in the previous video we talked about as p gets closer to 0.5, and obviously as n gets closer to infinity, because when you multiply n by p or n by q you'll get big numbers, the distribution of the proportions will become closer and closer to the normal distribution. So on that central limit theorem we had just these things, so that the mean will be mu, the standard deviation will be sigma over square root of n. Okay, so the expected value of the proportion is the expected value of x, which is the mean, which is p, and the standard deviation of p hat will be the standard deviation of the distribution, which will be sigma x, which is sigma over root n, which will be p1, so which is going to be pq over n. So we've had that before. Okay. So come across when you're ready. Copy that, come across. So again, we've talked about normal distribution last semester or last term, and we had z-scores, where you had score minus the average over standard deviation. And so we're going to be applying, rather than having, measuring what proportion of people were between scores, we'll be doing with proportions. So here's an example. So what percentage of values of the proportion would lie between 0.45 and 0.55 if p was 0.4 and the sample size is 80. So the first thing we do is we check NP and NQ so that they're both bigger than 5, and if they're bigger than 5 we can use the normal distribution. So that's going to be the case in most of these. So basically what's happening is we've got the normal curve, we've got the mean is 0.4, and we're trying to find the probability that the sample is between 0.45 and 0.55. So we're trying to find the area under the curve once we know the standard deviation. So mu is 0.4, standard deviation is pq over n, which is 0.005. So our z-score will be, first z-score for the 0.45 will be 0.45 minus 0.4 over 0.005, and I'm looking for my calculations for that one, and I've got 0.913, and for the second score 0.55 minus 0.4 over 0.055 is 2.739. So here's our z-scores. So so if we're going to have a 0 in the middle, we're looking for a 0.9 and a 2.7, and we're trying to find the area under the curve between those values. And so what we need to do is look up our table of standard values, okay? And if you do that, you'll find that the area equals 0.18. So about 18% of scores lie between 0.45 and 0.55. So this value here, you've got to look up your standard normal table that you've still hopefully got. If you haven't, then we'll have to print it out again. But so you've got to find the area behind 0.913, the area behind 2.7, and then subtract those two numbers, and that gives you 0.18. Okay, copy and come across. Okay, so we've got another example. Approximately 15% of Aussies are left-handed. Didn't know that. What's the probability that in a sample of 200 people from between 20 and 30 are left-handed? Okay, so let's just work this one again together. Okay, so NP, we've got 200 by 0.15, which is 30. 200 by 0.85 equals 170. There's my 200 people. Both those answers are bigger than 5, so we can progress on. Okay, so the mean is 0.15, so the standard deviation is 0.15 by 0.85 over 200, and according to my calculator, that's 0.252. So can you just check that number out, make sure that's right. Now, because we're going to be between 20 and 30, we can't start at 20, we've got to sort of come from either side so that we sort of take 20 with it. And so with this one, they actually say take 19.5 out of 200. Okay, so that's, so rather than doing 20 and 30, because 20 is included and 30 is included and it's a continuous variable, we sort of got to take it a little bit either side. So we've got 19.5, so that's the proportion minus 0.15, and we divide by 0.252, and according to my calculator, that's about minus 2.1. Okay, so that's the first z-score. Now the z score is we want to take 30, but we've got to take it with us, so we're going to take 30.5 over 200 minus 0.15 over 0.252, and according to my calculator, that's about 0.1. Okay, so there's 0, and there's 0.1. I'm not drawing it to scale. And so what we're trying to find is the area between those numbers. And so what we do is we find the area behind minus 2, find the area behind minus 1 using our table of values. And according to my answer that I got the area was about 0.52, so we got about 52%. So 52% probability, so I'll take that off. So there's a probability of 52% that between 20 and 30 people were left-handed. Okay, and that's how we do it. Okay, I think that's our last slide. So copy that down and come across, and there's an example, some examples to do. Okay, bye.